Hi students, MCQ number 4. There are two identical charged metallic spheres A and B which repel each other with a force 3 into 10 power minus 5 Newton. Another identical uncharged sphere C is touched with A and then placed at the midpoint between A and B. So the net force on C has to be determined. So very brilliant question. So first we have to read and understand the situation. So two metallic spheres, they are charged equally and identical charges. So if Q is the charge appearing on A means then Q is also appearing on the sphere B. The distance of separation between the two spheres is R. So what is the repulsive force between the two metallic spheres? So that is equal to F. So the constant K is equal to 9 into 10 power 9. So K into the product of the charges is Q into Q. So that is Q into Q is Q square divided by the distance square is R square. Okay, and its value is given as what? 3 into 10 power minus 5. So this is 3 into 10 to the power of minus 5 Newton. First, are you understanding the given information? So the force of repulsion between two identical charged spheres I have written and its value is given as 3 into 10 power minus 5 Newton. Okay, what next is happening? Another sphere C is brought. Suppose let us say that this is the sphere A. Okay, this is the sphere A and it is holding a charge Q. Now an uncharged metallic sphere is kept in contact. Uncharged metallic sphere is C. It has no charge. But when it is in contact with the charged sphere A and then removed, and then it is removed, so that this is A and this is C. Now what will happen? When two conducting spheres are in contact and then removed, the charge Q will be equally shared by both the spheres A and C. So the charge Q by 2 will be present in A. The remaining charge Q by 2 will be present in the sphere C. Okay. So what is given? Another identical uncharged sphere C is touched with A. So it is touched with A and then removed and then placed at the midpoint between A and B. Okay. So the midpoint means this distance is R by 2. So the other distance also is R by 2. This information are you understanding? Midpoint means the total distance is equally divided. Yes children, now you tell me what is the charge remaining in the sphere A now? It is Q by 2. So here the charge residing is Q by 2. And the charge in C also is what? Q by 2. Okay. But B is undisturbed, is it not? The sphere B is undisturbed. So how much charge will still remain there is Q itself. So here it is Q. Okay, now you see how many forces are acting on this sphere C. There are two forces. One is due to the sphere B, the other one is due to the sphere A. Understand that? So now there are two forces acting on the sphere C. One force, it is repelled towards B. Okay, so this is F A because it is repelled by A towards B. At the same time, it is also repelled by B towards A. So there are two forces. Okay, so FB and FA. Now these two forces FA and FB are acting on the sphere C. Now they are not equal. They cannot be equal. Why? Because the quantity of charge in the sphere B is greater than the quantity of charge residing over the sphere A. Therefore, FB is greater than FA. So the net force acting on C must be equal to what? FB minus FA. So F net, okay, F net must be equal to FB minus FA. So now this is equal to, so first of all we will write what is FB. FB is equal to the force exerted on the sphere C due to the sphere B. So this is equal to K into, so what is the product of the two charges? Q by 2 into Q. So K into Q by 2 divided by distance square is R by 2 whole square. So this is R by 2 the whole square. So this is now equal to K into Q is Q square, okay, Q square divided by this 2 is coming down, okay, 2 into R square by 4. So this is R square divided by 4, okay. So this 2 can be cut with the 2 and this 2 is coming to the numerator. Therefore, FB is now equal to 2KQ square, 2KQ square divided by R square. So this is the expression for FB. Similarly, FA. So what is FA? You look at this force FA, that is with this force only C is repelled towards B. It is exerted by A. So it is a force between the two spheres A and C. So this is equal to K into Q by 2 into Q by 2. Look at the charges, Q by 2 into Q by 2. So this is Q by 2 into Q by 2 whole divided by the distance square. R by 2 whole square is what? R square by 4, okay. So this is now equal to K into Q square. So K into Q square divided by this 2 and 2 make a denominator 4 into R square by 4. So this is R square by 4. So this 4 can be cancelled and hence this is equal to what? K into Q square divided by R square, okay. So step by step we have to get the expressions while learning. This is the beginning stage. Understand? When you practice any problem systematically, you will have to substitute and get the expressions for FB and FA. So what is asked here? Net force on C is asked. Therefore, the net force acting on C is equal to what? FB minus FA. So that this is equal to 2 into, so 2 into KQ square by R square minus KQ square by R square, KQ square by R square. So it is just like 2x minus x, that is equal to x itself. So this is equal to what? K into Q square divided by R square itself. So what is the net force now acting on the metallic sphere C? That is equal to the original force itself. Original force was what? K into Q square by R square, that is equal to what? 3 into 10 power minus 5 Newton. That is the original force which was acting between A and B in the absence of C. So we get the same force itself. Therefore, what must be the option here? It is option D. Okay, 3 into 10 power minus 5 Newton. Therefore, option D is the correct answer. This type of problem, though it appears to be simple, see, when you solve it by systematic approach only, you can understand easily. But it is very important, has been repeated many times in the competitive exams. I hope you must have understood well. Fine.